Oh, can you hear me? All right, cool. Give me a sec. Hi, everyone. Thanks for coming to hackTAMS. We hope you enjoyed hacking on your projects and learning a thing or two. And today we're going to get, right now, in about a minute, we're going to get started with some live demos. So stick around for some cool hack projects. Okay. So we're going to get started with our live demos. First, we have Emmanuel and his team for Killer Eye.
Hello, people. Our team is Killer Eyes. Okay, is somebody not on mute?
Give us a second. We're some technical difficulties real quick.
I'm not connected.
Unmute that.
I'm not connected. Can everybody on the demo backstage mute themselves?
I think you guys are good now. Oh, now you guys are on mute. Make sure you unmute StreamYard. Or maybe close out of Discord. We can't hear you guys. Maybe try stop sharing and share your screen again, or rejoin your StreamYard. Okay, I can hear you guys now.
All right, sweet.
Okay.
Cool.
Okay, so our team is Killer Eyes. So speaking seriously, around 20,000 people a year face liver or organ failure suffering under Wilson's disease. So Wilson's disease is an inherited disorder that leaves your body to be unable to dispose of copper, leading to a buildup that will most likely kill you when you turn 40 years old. So this is easily diagnosable through Kaiser-Fleischer rings or a visible copper ring around a person's eye.
So we focused on the population that can't access normal healthcare facilities. So what we did is we coded an application that uses the Kaiser-Fleischer rings. It scans your eyes and it tells you whether or not you have Wilson's disease. So Sam will talk more about it.
Our primary solution to kind of fix this was an application that would take a picture or live footage of your eye and use machine learning to Kaiser-Fleischer rings. Yeah, using TensorFlow.
And neural networks. So here's a live demo. So the first thing we have to do is initialize the live webcam feed. So here we go. So as you can see, because I am not an eye, it says no eye detected. But once we have a picture of an eye with Wilson's, it'll show up that this eye has Wilson's positive. If we use other eyes, you have the other data.
Hey, Emmanuel. Emmanuel, can you guys lower the volume on your end? Like lower the volume on your laptop?
Yeah. We'll do that. I think that's what was causing the issue.
Yeah, try that now.
If you want us to restart,
right.
We can.
Yeah, that would be great. Yeah, so people just tuning in, Emmanuel and his team's gonna present Killer Eyes, which is a project they developed for hackTAMS. So yeah, go ahead and start your presentation.
You guys good now?
Okay. Let's give us we have one thing just for reference.
Yeah, I'm just trying to fix it. Yeah.
Wait.
Yeah. Okay.
Wait. Just okay. Pass me my phone. Okay. Bro. Okay. So if we had a picture, so here's another thing that we can do. If we want to upload another image for testing, this is our data set that we used for testing that was not trained in the actual model. This is an image with no Wilson's, right? And as you can see, it processes the images that we upload and gives us the live result that it is Wilson's negative, which in this case it is. So basically, we just built the detection app. We also built like a Google Sites, which you can see in our project summary in the link below, I guess, in the live demonstration. But yeah, that's about it.
Thank you. And excuse any
Thank
technical
you, but
difficulties.
excuse any technical difficulties.
Do you guys maybe want to go through some of the technical details of how you made your hack?
Yeah, so our app was, okay, let me pull up this index.html stuff. So as you can see, we coded it in HTML. We used like a lot of Java, and then we got our image, we got our TensorFlow model, and then we essentially just ran a couple. So we got the model from Google Cloud servers, and then we essentially ran all the processing on a local computer. So all the predictions and all of that kind of stuff was done locally. So this app would work offline if you downloaded the model separately and just like imported it into the app. So if you got like a Raspberry Pi setup, you could run this locally in certain areas.
Awesome. Great job, guys.
Thanks.
Yeah, who's
Yeah, we're just waiting on our next group to join the live stream. So it's gonna take a few minutes, but yeah, I hope everyone's been enjoying attending hackTAMS. It's been a lot of fun on the organizing side. We had over 250 registrations, and we had students from like over 40 different schools across the United States and the world. So it's been a blast just to get to interact with that amount of diversity and people just across the world. Hopefully we'll have our next group that's up, but yeah. How about we do a fun activity? So type in the number of hours you slept last night. I know hackathons are a bit crazy for lack of sleep. 2 hours. Jeez. You guys. Man.
more than
All
expected?
right.
That's good.
Yeah.
That's
Rohit,
good.
how much did you sleep?
Did I sleep? Like 4 hours maybe? Or a little
4
bit less,
hours?
a little more. I went to sleep really late and then I woke up late. Overslept, I feel you.
Yeah.
I think waiting for Better Hack to get set up real quickly and we'll get them on for their live demo in just a few minutes.
All right. I think our next group, Arman and Arjun are ready to do their live demonstration. Their project is called Better Hack.
Hey,
Hey, Arman.
hello. So our project is called Better Hack, and it's pretty cool. and I'm gonna share my screen so that we can take a look at it. So this is BetterHack. It's basically, the Home Access Center, which is a grade processing service, and I think Arjun actually might be sharing his screen. So we may need to switch to that one because he has the code running. So, okay, there we go. So Home Access Center is like really clunky and bad, and it's the way that most of the schools in our area get their grades. And what that means is that in order to get your grades, it's really slow and it's not really efficient at all. And we saw that and we thought we could improve it. So what we decided to do is we'd reverse engineer how they take their level requests. I mean, not their level requests, their network requests, and we'd store it in a database. And instead of querying them every time we get our grades, we'd query the database. That way we would speed up the process of getting our grades a lot. And that way we could also do cool things, like in the future we can send notifications and we can do other things based on the grades and how they were working. So Arjun, you can talk more about the technical aspects.
So you guys can hear me, right?
Yep, you're good.
Yeah, so what I did was I used Selenium because of the amount of JavaScript that was used in the Home Access Center. And I made a web scraper out of ScrapeHigh, which let me handle all the backend of cookies and HTML, HTTPS headers. So as you can see here in the console, I have gotten all the data from all my classes. So all this data is then sent up to our MongoDB cluster that we stored locally. And it's currently just holding test data because we do not wish to share our own info. And once you view the page, you can actually see your test grades, your assignments, even your latest assignments. And we have interactive graphs, which you can actually view how your progress over time of using our application has gone.
So for the front end, we basically tried to make the hack experience as much as we knew it in the past, except a lot more modern. So what we tried to do is we tried to add more analytics and more things that we could use to control and show how everything was more visually instead of just having numbers on a table. So you can see the graph that shows like your grades over time and how they've improved throughout using the hack scraper. And then as you go down, you can see all of your grades. And instead of doing it in a way that shows you all of your grades in their courses, we show you the most recent grades added to the gradebook. So that way you don't have to scroll through miles and miles of text in order to just find your most recent test grade. It's just at the top. So those were a few things we were basically making this for, so that it would be easier to check our grades and to check what we had that was different than the last time.
No, that's great, guys. Yeah, I used to use Hack before. Super clunky and boxy. This is amazing. Yeah, great job, guys.
Thank you.
Thank you.
I think, yeah, that was a great presentation by Aman and Anjan. We're right now waiting on our next group. Yeah, this will be a little bit.
Okay, cool. So next we have Project Oasis, and they're setting up real quickly, so they'll be on in just a few minutes. Or
Okay.
you guys are free to share your screen and start presenting whenever you're ready.
Okay, Kadir, you want to start or should I?
You're muted. You're muted.
Just hit
you have
unmute on StreamYard,
on
like at the
stream.
bottom of your screen. Just say mute.
Here,
Yeah,
I can
you're good.
I can hear you y'all. Can you hear me?
Yes. We
Yeah,
can
you're
hear
good. You're good. No, this is Oasis.
you. Okay. Do we want to just go straight into the demo, or Kadir, can you briefly explain what it is?
Okay, so basically, okay, so our project is Oasis. My name is Kadir, and I also have Dhruv here with me. And our project basically stands for optimization of airfoil systems. So a little overview about our project. So first, let's talk about what an airfoil is. Oh, hold on 1 second. Okay, I think I'm gonna have to restart. Can you give me like 2 seconds?
Yeah, 1 second. Yeah, we can.
Hey, Dhruv,
you
get on
can see
private
my screen.
chat.
Okay.
So that's good to go.
Okay, I'm on mute. I'm on mute. Yeah. Okay. Essentially, what our program does is we created a system to optimize the bet. Okay. We created a system to optimize the shape of an airfoil in order to maximize the lift and minimize the drag. So these are the different inputs you can give. I don't know. Can you guys see that? No, you can't. Okay, let me share that. Share screen. Okay, so this is how you can. This is just for testing. So with this one, you can make your own airfoil, like your own custom airfoil. So say we, the way this works is you can provide a camber position, a thickness percent, and the number of points to graph it with. Essentially, what the camber is like the maximum percentage of the chord. The maximum camber position is where it is in relative to the chord, and the thickness is the percentage it is relative to the chord. So let's set that to 40, 40, 12, and let's graph it with.
Are you sharing? Are you sharing your screen?
Yeah, I am sure. Can you not see it?
No.
How do I get? Okay.
Yeah.
Sure.
Okay. Yeah, you're good.
Okay. I might have to share and unshare because, yeah. Okay, so I'm gonna update the plot now, but that's a separate window. So I'm gonna unshare and share real quick. Can you share screen? Sorry for the inconvenience.
Yeah, you're good. You're good.
Figure 2. So it has to be shown now. I shared screen.
I don't think we can see it.
I think. Okay, yeah, I think the host has to.
Now we can see it. We can see it now.
Okay, so essentially what this is this is the airfoil generated by those parameters we are inputted just a while ago. So as you can see, this is just an example of an airfoil. But now I want to go into the optimization part. So I'm gonna stop again. This is kind of okay. So what I'm doing now is this is offering the parameters that the airflow will be in. So we're going to optimize the lift and maximize the lift and minimize the drag of an airfoil in these parameters. So it's going to take a while to calculate all of this. So if you're interested, I can show the code. Where is it? Yeah, here. This is what it's running. It's running Xfoil, which is a airfoil simulation software, in order to. Oh, you can't see that, but it's running Xfoil, which is an airfoil simulation software, and what it's doing is it's essentially simulating that to get the drag. Okay, it's up now. There. Let me share that. I'll just share my whole screen. Wait. Oh no, it crashed. Okay.
Do you want to go through the presentation?
Yeah, let's just go through the presentation.
All right.
Here, you can share. I'll stop sharing. Let me get out. Do you want me to get it out, or? Oh, let's just go through the code actually.
Oh, you want to go through the code? Because
Yeah.
am I sharing screen right now or what?
Yeah.
All right,
Yeah,
there we
yeah,
go.
we can see it now.
Okay, so present. And
I don't think we need to go through all of this. Let's just hear the code.
all right, so to quickly like explain what an airfoil is, it's like the cross section of the wing of an airplane. So if you look at this right here, it's basically like the shape of the wing. So so an airfoil is designed to make higher pressure under the wing and lower pressure above the wing. So it creates like a natural lift force, and that can help the plane increase elevation. So yeah, like we talked about, our project uses Python and uses a module called PyQt5 for the user interface, and it also uses Xfoil for all the calculation parts. And so, like Dhruv said, you can like change the max camber position, thickness, and scale, and it'll give you an optimized result for such as the angle of attack and the best type of airfoil to use in a given environment. So, Dhruv, do you want to talk about some of the math stuff?
Okay, so essentially the most important equations we use were the lift equation, which you can see down there, the air pressure, or the density of the air, the angle of attack, and the Reynolds number, which is kind of, if you've heard of laminar flow, it's kind of measuring the turbulence of the air or the fluid or whatever the airfoil itself is moving through. So the lift equation is below. Now Kadir can go into more of the more in-depth physics of the airfoil.
Yeah, so these are all the forces that are acting on the airfoil, and the black lines represent the airflow. And as you can see, the wing makes it like go more toward the ground and not just toward the side. And the two main forces we are worried about here is the lift force and the drag force. We want the lift to be as high as possible and the drag force to be as low as possible. So our program can find it'll run through multiple combinations and find the most optimized or the highest lift for the lowest amount of drag possible. So some of the challenges we faced was this is our first time using many of these modules, including PyQt5, and this is like very math and physics focused. We had some functionality issues with the modules, and we had like not use some certain tools because it just wouldn't work. So there's a lot of application for this project. So it can be the very good thing about this is you can make your own airfoil, and you can like make an optimized airfoil for whatever situation you need. So you can specify how fast you will be traveling, or how fast or how dense the air is, or even the Reynolds number, which is like the viscosity of the air. And it'll give you the system will give you the most optimized NACA airfoil. So yeah, so we're just gonna be doing our demonstration now.
Okay. Here, let me share the actual.
Can you
I
share
already
your entire window?
I talked about most of it. Okay. 1 second.
So we can just run through the code one more time real fast.
Okay, I'll just share my entire screen. There. Can you guys see it? I don't know if I should share the entire.
Yeah.
Screen.
Before we go through the code, do you guys want to talk about, maybe you got a question about like maybe who this tool is maybe aimed at, or the demographic you guys are looking at?
It's aimed more towards engineers designing, like. Here, let me look at the Twitch chat real quick. It's aimed more towards engineers that are designing like wings or things like that. So,
So like aircraft designers.
Yeah, aircraft designers.
Yeah, and if you look
they
at,
want to maximize lift and they don't want to go through all the math and do it themselves. This is for them. So, like with the parameters we talked about earlier that I was showing off, here's the optimal NACA. So this is the camber and all of the stuff.
Let me zoom into your code. It's kind of.
Oh yeah, I don't here. And this is just the GUI code. So we use PyQt5. Do you want
to? So can you start from the beginning and try?
Okay. Yeah, let me go for the code. Okay, I'll run it one more time, and I'll run it one more time. Okay, I'll have it run while we're talking. So this is just the airfoil thing, so I'll put it over here. Let me set the Reynolds number to 100, density to like 23. I already demonstrated most of this before, so I'm going to show the output now. So that's going to take a while to process. So while that's processing, let's go through the code. So optimize.py. This is what actually optimizes for the airfoils. So originally we were going to use like a more advanced algorithm, but in the end we couldn't do that because it was just taking too much time. Even now it takes like 30 seconds. So right now we're just iterating through each of these and finding using whichever one is the best. Okay, it just finished optimizing it. So essentially what it's doing is finding using Xfoil, which is a software made by like MIT researchers to simulate airfoils, and it finds the coefficient of lift and drag, and it finds the ratio of those, and then it just returns which one out of these. I try to represent as many different types of airfoils as possible. Originally we were going to use gradient descent, and that's what we would use optimally in the future if we could make it more efficient. And now let's talk about the GUI.
So the most of the code is in the main.py section, and the main.py, the thing about that is it's like 600 lines, but like 90% of it is just GUI. And what we're doing is we're grabbing the values from the sliders and the buttons we have in the GUI, and we're using that to plug values into the optimize.py class, and using that we're getting the method. So this project is like, well, I guess it has a lot of application per se, but yeah, this is just something we worked on in like the past like 10-12 hours, and yeah, thank you for watching.
Okay, and this is the optimal angle. So this is the optimal airfoil I was talking about earlier. With these parameters, this is the optimal airfoil. Okay, I guess that's all then. Let me stop sharing.
Great project, guys. Love the.
Thanks.
Really tell you put a lot of time and thought into developing it.
Thanks a lot.
Thank you.
Thanks for presenting, guys.
Alrighty. Those are some great projects. I think we are at the end of the live demo session. So thank you everyone for tuning in. We hope that you guys really enjoyed all the projects that all our hackers had to present. We hope all the hackers enjoyed the event we organized. And we're just really happy that everyone was able to show up. But thanks everyone for tuning in for live demos. Closing ceremony is going to be at 6 p.m. Central Standard Time today. So tune in for that to see if you won any of the awards.